Pull up a chair, get comfortable. Today, we are jumping right into one of the 20th century's absolute wildest feats of engineering. In this explainer, we're not just looking at a static monument. We're literally climbing up the scaffolding to uncover a crazy story of raw ambition, mechanical genius, and just sheer willpower. I mean, really ask yourself, how do you actually sculpt a mountain? Think about it. How does human ingenuity take an unyielding 5,725-foot chunk of wild granite and transform it into living, breathing art? It sounds like some ancient myth, right? But the mechanics behind this colossal achievement are 100% real, and honestly, they're absolutely fascinating. To anchor this, we're going to borrow a thought from Papa, the author of our source newsletter, because he really hit the nail on the head here. As an engineer himself, he points out that this whole thing is a tribute to vision, dedication, persistence, and creativity. This isn't just a story about rocks and chisels, It's a massive celebration of human persistence. It shows us exactly what determined hands and minds can pull off when they refuse to let a literal mountain stand in their way. So let's set the stage. Act 1. The context. The sculptor, Gutzon Borglum, didn't just pick any random rock. He went looking for this specific, south-facing, magma-formed stone called Harney Peak granite. And the reason why is mind-blowing. This specific rock erodes at a microscopic rate of just 1 inch every 10,000 years. Borglum wanted this thing to outlast civilizations. He deliberately chose an eternal canvas, fully knowing that carving it would mean battling one of the hardest substances on the planet. And to make matters tougher, just look at the utter isolation of the Black Hills. This rugged, completely unforgiving terrain was a logistical nightmare. You had 400 local workers, miners, lumberjacks, ranchers, navigating this wild environment day in and day out. There were no modern highways, no heavy lift helicopters dropping off supplies. It was just rugged landscape and sheer human grit. And that grit, it was tested over 14 long years, from 1927 all the way to 1941. Through the biting bitter cold of winter and the absolute blistering heat of summer, these guys labored year-round. Imagine just being suspended hundreds of feet in the air in a little swinging bosun chair, held up by nothing but a 3/8-inch steel cable while the wind is just howling around you. That is the intense level of dedication we're talking about here. Which brings us to Act 2, the tension. So how do you actually translate a tiny studio model onto a giant cliff face? Well, you use some serious mathematical genius. Borglum used something called the pointing system, which is this really cool ancient technique dating all the way back to the Greeks. They basically mounted this massive protractor on the mountain with a pivoting beam and a plumb bob. And the math was perfectly scaled. Every single inch they measured on Borglum's plaster model translated exactly to 12 inches, 1 foot, on the granite face. A tiny 1-inch tweak in the studio became a precise, massively scaled-up calculation on the rock. The really crucial part is how they executed the rock removal. It was this masterfully orchestrated 3-step process. First up, brute force. They used dynamite to blast away the bulk of the stone. Then they moved to a technique called honeycombing, where they took pneumatic drills and bored holes super close together to weaken the remaining rock. And finally, bumping. That's where they used a 4-point pneumatic bit to delicately smooth the surface right down to the skin of the faces. Now, the sheer scale of that first step is just staggering. 450,000 tons of granite were blasted off the side of that mountain. And these powder men, they were so insanely skilled with their dynamite charges that they could blast the rock to within just 3 to 5 inches of the final facial features. It was literally an explosive ballet of precision. But here's the catch. None of those pneumatic drills or bumpers worked without power. The literal lifeline of this entire operation was this massive 1,800-foot, 30-inch wide pipeline. It ran parallel to this grueling 506-step stairway, right up the mountain, pumping compressed air from the base all the way to the workers at the top. And get this, to stop the tools from freezing up in those bitter South Dakota winters, they actually came up with the genius idea of pumping a misty gas right through the pipes. Of course, nature doesn't really care about your blueprints, does it? The original plan actually had Thomas Jefferson carved on George Washington's right. But once they started digging in, they found the rock there was just completely unstable. But they didn't quit. Instead, they literally blew up the initial work with dynamite and completely relocated Jefferson's 60-foot face over to Washington's left. Talk about adapting and overcoming. And the adaptations didn't stop there. As Jefferson's face was finally starting to emerge, they discovered this deep, natural crack in the granite heading straight through his nose. Now, a lesser team probably would have just abandoned the spot entirely. But Borglum, he creatively pivoted the president's head just slightly to the left and tilted it upward. This brilliant little geometric shift moved the crack away from the center of the nose and into the cheek, where it hides in the shadows to this very day.
Let's move on to Act 3, the connection. I like to think of this as a super powerful visual metaphor. Just like those sculptors hanging from the cliffs, we rarely get to force our exact blueprints onto the world, right? Life has natural fissures, unexpected cracks, and unstable ground. If we want to achieve our own monumental goals, we have to be willing to shape our ambitions around the realities we actually encounter. We have to pivot our approach without losing sight of the vision. And I really want you to remember this detail. This entire feat was achieved without modern computers. No 3D laser scanners, no automated, GPS-guided machinery. It was pure, unadulterated human adaptability. It was a rising tide of collective effort, 400 people working in total sync with gravity and the mountain's character to overcome what looked like an absolutely impossible physical barrier.
Bringing it all together, the synthesis. What we're really looking at here is a master blueprint of persistence. It requires vision, the ability to see something incredible locked inside an unyielding obstacle. It requires precision to actually execute the plan, step by step. It demands persistence to just keep going for 14 years through freezing cold and real physical danger. And maybe above all, it requires creative adaptability, the willingness to pivot when you inevitably uncover hidden flaws. Monumental achievements, they always require way more than just raw force.
Like Papa pointed out, Mount Rushmore is indeed a profound tribute to dedication and creativity. It really leaves us to marvel at what determined human hands and minds can carve into the crust of the earth. So I'll leave you with this final thought. When you face an unyielding mountain in your own life, will you turn back or will you pick up your tools and start carving?